Hey guys, I'm Jade. Today is my LeetCode review vlog on the 169th problem, majority element. And let's get started. We are given an array nums of size n, and we have to return the majority element. The majority element is the element that appears more than n divided by 2 times. You may assume that the majority element always exists in the array. And let's see the example. Example 1, we got a nums input, which is 3, 2, 3. So 3 is the majority element because we have 2, 3, and we have just only 1, 2. And let's get started. So for the method of approach 1, we could have a most straightforward intuition, which is we can sort the arrays and found the middle element. Because the intuition behind this approach is if our element occurs more than n divided by 2 times in the array, it will always occupy the middle position where the array is sorted. So we can sort the array and return the return element at the index of n divided by 2. So in Java, we can use this function, this method, arrays.sort, to sort the whole elements. Then we return nums of n divided by 2. This is the most straightforward intuition, which is very easy to understand. Oops, there's something wrong. It should be n nums dot length. So for this approach, it's very easy to understand. It has the lowest code, the least code. Yes, we got accepted. And let's analyze the time complexity and space complexity. So for the time complexity, we used the arrays.sort method to sort the array, and the base principle of arrays.sort is quicksort. So the time complexity is big O of n times log n. And the space complexity is big O of 1 because we didn't use any extra space for that. Then we also have another approach, which is, I would call it the second approach, which is the hash map. We can use 2 hash maps. So for the first hash map, let's create a hash map first. So for the first hash map, so the value should be an integer, and the key and the value should also be the integer. So the key stands for the num, stands for the value of the element, and the value stands for the occurrence time of that value. Can I say it? Element occur times new hash map. Then we can use 2 for loop to solve the problem. So for the first for loop, we have to traverse the array to collect the occurrence time, the occurrence times of every element. Then we got for and int I equals 0, and the condition should be I less than nums.length. Then we increment I with plus plus, and in each iteration we have take out the element, which is element occur times, put value, which is nums of I, and we have to get the nums. So we can use the default method, which is element occur times get or default. You can use the method to get or default ith the value, which is nums of I. If we didn't get the value, so we have to assign our default value, which is 0. Oops, it should be 0 because we have found the element, so it should be 1. Should be 0, and then we plus 1. So this is the first for loop, and in the second for loop we have to traverse the hash map to find the biggest occurrence times of every element. First for loop, find the element has the biggest occurrence times. So we have to iterate map.entry, which has an integer key and integer value. And if the entry dot get value is bigger than nums dot length divided by 2, which means we found the majority element, because the majority element occurs more than n divided by 2. So we return entry dot get key. And if we don't find a solution, we can return a different value to tell them our method didn't find the majority numbers that they are looking for. And let's run our code. Oops, there is something wrong. Array of iterable. Oops, it should be right down in entry state. We have to get it from the entry state. Element occur times dot entry state. Yes, it got accepted. So this is the second approach, which we use a hash map to traverse the array to collect the occurrence times of every element. Then we have to find the element who has the biggest occurrence times, and this value, it is what we are looking for. And let's talk about second approach, time complexity and space complexity. So for time complexity, which is big O of n, because we just traverse the nums for only 2 times. And for the space complexity is also big O of n, because we use an extra hash map to store to store every element and their corresponding occurrence times. So this is the approach 2. I think it is more public and more general to solve the problem. But as the problem said before, can we solve the problem in linear time and didn't use any extra space? The answer is yes, but that approach is very hard to imagine or to come up with. Let's get to it. So we can change the name and copy this method here. So the approach 3 is a very famous algorithm. It is called Moore voting algorithm. So the simple explanation is this algorithm is based on the fact that if there is a majority element in the array, it will always remain in the lead even after encountering other elements. So let's start with the code. First, we have 2 variables. So the first is occurrence times, and we initialize the variable to 0. And then we have another candidate, which means candidate is the value we are checking if is the majority element so far. Then we have a for loop. We can init I with 0, and when I is less than num stop length, we have to continue this for loop. After each iteration, we have to increment I. So inside the for loop, in each iteration, we have to check if the occurrence times is equal to 0. If the occurrence times is equal to 0, which means we found a new candidate so far. So the new candidate should be nums of I. And then we have to check for the value if the I is equal to the candidate. If I is equal to the candidate, we have to increment the occurrence times, else we have to decrement the occurrence times. Sorry, it is not I. It should be nums of I, because we have to check in every element. If the new element have the same value with candidate, which means we find another same new candidate, so we have to increment its occurrence times. On the other hand, if we find a different value candidate, we have to decrement its occurrence times. And in each iteration, if the occurrence times equals 0, which means we need to take another new value as a new candidate. And after the whole loop, we at the final, we have to return the candidate, because the more voting algorithm says, the majority element should always be remaining, even if it meets any different candidates here. And let's check the answer. Yes, it is got accepted. And for the more voting algorithm, the time complexity is big O of n, because we just traversed the arrays for only one time. And for the space complexity, it is better than the second approach. It is big O of 1, because we only use three variables to solve the problem, which is occurrence times, candidate, and iterating pointers. In my personal opinion, more voting algorithm has the best performance, but I think it is very hard to come up with this algorithm to solve the problem. So I think for more coders, the second approach, HashMap, it is more convenient and easy to understand, and is more general to solve all different problems. And thank you guys for your watching. This is the end of my vlog on the 169th problem, majority element. If you would like to check the notes for the problem, you can also visit my GitHub repository. I put this link in my YouTube description below. Thank you guys, and see you next time.